Greetings everyone, and welcome to this video on input options for the Bayesian independent samples t-test. Building on the previous video, after we have assigned the variables in their boxes in JASP, we would now like to explore some more input options for the test. Since we are exploring the adequacy of the one-tailed alternative hypothesis that the treated group is more likely to show higher reading test scores, we have selected this checkbox under the alternative hypothesis section. If a two-tailed alternative hypothesis needs to be explored, suggesting near inequality of population means, that can be achieved by checking the first option. Proceeding further, underneath the base factor option, which is a measure of the strength of evidence, the BF10 provides the base factor to quantify evidence for the alternative hypothesis relative to the null hypothesis. The BF01 provides the base factor to quantify evidence for the null hypothesis relative to the alternative hypothesis. Lastly, the third option is the natural logarithm of the BF10 or the base factor 10. Now, dropping down the prior section, if we had relevant background knowledge or information about the size of the effect, we could incorporate the value here. But in this case, since we don't know the effect size for this study, we will leave it at the default value of 0.7077 or the scale. The prior is described by a Cauchy distribution centered around 0 with a width parameter or a scale of 0.707 or 1 over root 2. This corresponds to a probability of 50% that the effect size lies between negative 0.707 and positive 0.707. The prior and posterior option displays the prior and posterior distribution of the effect size. The base factor robustness check displays the base factor as a function of the width of the Cauchy prior on effect size. The sequential analysis displays the development of the base factor as the data come in using the user-defined prior of 0.707. And yes, that's it for this video. Thanks for watching, and I'll see you in the next video, which explains how to interpret the output.